Hello and welcome back to Physics Safari. My name is Abhishek and today I'm going to do the continuation of the graph where I've left in the previous video. So in the previous video I have discussed the fundamental of graphs and I've taught you the technique how to deal with the graph. And today I'm going to do a few practice questions on the graph. And I'm sure you must have seen the previous video. If not, do watch that before you watch this video. The link would be given in the description as well as in the I button. All good? Baniya. In the previous video, I have taught you what is a velocity time graph, displacement time graph, acceleration time graph. So today I will be discussing with you the distance time graph and the speed time graph. And I'm going to show you what is the difference in the distance and the velocity, displacement, velocity and the speed time graph. Those are the major things that we're going to cover up today. Now, so let's continue with the same example. Let's suppose when the body was thrown upward with a velocity u. So it will go up, and it will come down. It will take some time to complete this motion. So let us say that it took some time t to go up and it took the same time to come down. I want to draw speed time graph. I want to draw the speed time graph. I want to do speed time graph. First of all, let us draw the velocity time graph that we have seen already in the previous class. So what exactly is the velocity time graph? For that, we have seen that we have to reduce the equation of the velocity and the time, and that's how we do that. So just a quick thing. So in that question, we have seen, okay, maybe I will just put it here. I'll just use it here. Okay. Now, let's say this is your V graph, this is your T graph. If you remember that initially speed was u, so time t is equals to 0, speed is, let's suppose, u. As it goes up till at the top, the velocity becomes 0. So, and it is going to be, acceleration is constant, so the graph is going to be linear. Slope would be negative. The reason is the velocity is decreasing. Now, at the same time, after the top, the body starts coming back. Does the acceleration change? No, that still remains the same, minus z. So the slope of the line will not change. Slope will not change. So this is going to come down. So that's how we used to get. And the time when it comes back to the bottom was how much? T is equals to 2u by g. And this time when it reaches the top was u upon g. And the velocity when it reaches the ground is again the same, which is u. That will not change. So this was your velocity time graph. Now I want to draw the speed time graph. अपने को speed time graph draw करना है जी. We know that speed will never be negative. If you look at this graph, below this the velocity is negative, but speed cannot be negative. So what exactly we do? We take the mirror image. We take the, where is the blue marker? Just a second. We take the mirror image of this. So this is gonna be your speed time graph. This should be your speed time graph. This one and this one. So you have to just take the mirror image of the negative velocity and that would give you the speed time graph. And the same thing we can apply in the distance time graph also. Hanaji, Baniya? Okay, great. So let's first of all draw the displacement time graph. Let us see the displacement time graph. Okay, now in this case, if you remember the displacement time graph, the body initially was going upward in the positive direction. So if you remember, the graph was, and it was deaccelerating, right? It was as in key, because the acceleration was in the negative direction, velocity was upward, so the body was slowing down. So the graph, if you remember, was like this. And in the second half, it was like this. Now we know that if suppose this is your displacement, this was your displacement, but now we are talking about the distance time graph. This is your distance time graph. Distance can never be negative also. If the body is moving in a forward direction or in the backward direction, the distance cannot be negative. Distance will be always added because it is all about the magnitude of the displacement. So, but after this we can see, after this point you can see that the displacement is coming back to 0. So what we're going to do to get the distance? We will take the mirror image of this. So tick, 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 tick. Mirror image should be how much? Like this. So this is going to be your distance time graph. The red one up above would show you the distance time graph. I believe you guys are okay with this. So this is how we draw the displacement time graph, distance time graph, velocity time graph, and the speed time graph. Also, let's suppose if I have the, you can say the velocity is given like this, somewhat like this. This is your, let's suppose velocity time graph. This is your velocity time graph. If I want to draw the speed time graph for the same motion, what exactly I'm going to do is, if I want to find the speed time graph, so we'll take the image of the negative part, as simple as that. So it is going to be like this, and like this. So this is your speed time graph. This is your speed time graph. This is your velocity time graph. Badhiya ji? All good? ठीक है. Let me just check if recording is happening properly. Yes, it's absolutely fantastic. Very nice. Now, having done this, let us do some questions. Let us practice some questions based on the graph. And I've also mentioned that in the graph we'll have two situations. One, they would give you the graph and you have to do the analysis, and otherwise they're going to give you the situations and you have to draw the graph. It could be xt, vt or at based upon the demand of the question. Chalo. So let us do a simple question. एक पहला start करते हैं. Let's suppose example 1. Let's say I give you a velocity time graph. I give you a velocity time graph like this. This is your velocity, this is your time graph. Now the body's velocity would be, let's say like this. From here it increased, became constant, and let's say came to 0. Let me just extend this. Here we have. Now let me give you the timings. So from here it is, let's suppose 2 here, 3 here. Okay. Now let's say tick 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 tick. Here we have 5, 6, 7 and somewhere 4. This data, this value of velocity, let us say this is 20 meter per second. So this is in meter per second. Now the question to you would be, draw the AT time graph. Draw acceleration time graph from here. Draw the acceleration time graph. You guys pause the video and then you try to solve it. Once you're done, come back, unpause the video and see the solution. Okay. Okay then, I'm sure you guys must have tried, give it a try. Now let us try and do it. If I want to draw acceleration time graph, we need to understand what is the acceleration from 0 to, let's suppose this is time t is equals to 0. Okay, and this, if it is a midpoint, let's suppose this is 2.5, my bad, this is 2.5 seconds. Okay, now let's say I want to draw the acceleration time graph. So here I'm putting this a value. We must have to do some calculations. अपने को कुछ calculations ही करना होगा. So let us suppose this is your acceleration time graph. Put some over here. From 0 to, let me just name it A, B and C. देखो ध्यान से देखना. Watch carefully. From O to A, the body's velocity is increasing. It clearly means we have some acceleration. There is acceleration. So let's suppose solution. So there is acceleration. There is positive acceleration, or simple say we can say acceleration. That's not a problem. How much? Velocity time graph. Slope of velocity time graph gives you acceleration. So the acceleration should be how much? Velocity upon the time. The velocity is how much? 20. Time is how much? 2.5. All good. So this should be how much? Let's suppose this 25, 5 times 5, 5 times 4, 80. This is going to be 8. So the acceleration is 8 meter per second square from 0 to A. So the acceleration from 0 to A is 8 meter per second square. So let's suppose the time is how much? 2.5 seconds. 2.5 second. Acceleration is a positive 8 meter per second square from 0 to 2.5 second. All good? Badhiya. From A to B, the velocity is constant. So this is a case of constant velocity. And if the velocity is constant, which means that implies V constant, that implies acceleration is 0. Here the V is increasing, that means we have a positive acceleration. So from 2.5 to 5 seconds, check out this the acceleration has to be 0. So this is your 5 second. Acceleration has to be 0. From B to C, the velocity is decreasing. That means we should have a negative acceleration, as simple as that. Since the velocity is decreasing, the acceleration should be negative, isn't it? How much? As simple as that. 20 slope upon, this is how much? 2. Since it's a negative acceleration, so you can write from B to C. From B to C. Change in velocity is how much? 20 to 0. It means change in velocity is minus 20. Negative 20. Time is how much? 2. So that's going to be negative 10 meter per second square. So from 5 to 7, the acceleration would be negative 10. It is going to be, okay, it's going to be negative 10. So this is going to be negative 10 meter per second square. That is it. So this is how you have to draw the acceleration time graph. Chalo, note it down, all of you. Meanwhile, I'm going to give you one question on the same. So here we have. Okay. So the question is, okay, next question number 2. Question number 2. So basically it is giving, you may write down, okay, so I'm working on the projector or maybe the smart board. For that would make your life easy in noting down the questions. While solving the questions would be in front of you, of course that's going to be helpful. Give me some time, guys, I'm going to get that done as well. Okay, anyways. So let's suppose the question is, so there is a scooter and a car, they're racing. Okay, so we have a velocity time graph is given. We have a velocity time graph, and it says, if you want, you can note down. As soon as the car just starts from the rest in a certain direction, a scooter moving with a uniform speed overtakes the car. Their velocity time graph is shown in the figure. Calculate, we have 2 questions. So first of all, let me draw the question for you. Let me draw the graph for you. So basically, there is a scooter which is moving at a constant speed, so at 30. It's a scooter. It is moving at a constant speed. This graph is for the scooter. It is moving at a constant speed of 30 meter per second. So this velocity is in meter per second. Okay, great. Now we have one car. So these are the some. So we have 30, 45, 60, and here we have 45. And we also have a car. We also have a car, which graph I'm going to show you is going to be like this. It is like this. It's first accelerated, and then it started moving at a constant speed of velocity of 45 meter per second. So like that. It's moving at 45 meter per second. All good? Now this time is, it's given as, let's suppose 5, and this time is given as 15. Okay, it's looking quite close by. Okay, no, this is 10. My bad, this is 10. 5 is below now. Now, and this time, final time is given as 30. Forget it. And the rest doesn't matter if the time is whatever it is given. Now, the question to you is, the difference between, you have to find the question number 1. Number 1, find the difference between the distance traveled by the car and the scooter. Find a difference between, so this is for the car. Find the difference between the distance traveled by car and scooter in 15 seconds. In 15 seconds, that is the question number 1. And number 2 says, the distance of the car and scooter from the starting point at the instant when the car catches the scooter. ठीक है, चलो जी, इसको हम लोग देख लेंगे. So basically, first of all, we have to find what? We have to find the difference between the distance traveled by the car and the scooter in 50 seconds. चलो, I'm going to erase this. Meanwhile, you guys give it a try. कोशिश करो. You can pause the video and can try this. And then you can unpause the video and watch the solution, and you can match your answers. If it is good, correct, all in good. If it is wrong, you can figure out where you went wrong. Okay. Now let us understand the graph. What's happening over here? तो यहाँ पे अपने को दिख रहा है, what we can see is a velocity time graph is given, well and good. We have two objects, one is a car, one is a scooter. The car is starting from west, whereas in our time consideration, whereas the scooter has a constant velocity of 30 meter per second and it is continuing moving with that sort of velocity. As we can see over here, in 10 seconds, the car achieves a velocity of 30. It does not mean that it is overtaking the scooter. No, it has achieved that velocity. Maybe in those 10 seconds, the scooter might have moved quite a far distance. So, okay. So, do not get mistaken that in 10 seconds, the car is going to catch the scooter. No, that's wrong, interpretation. Now, what happens after in 15 seconds, the car achieves its maximum velocity of 45 meter per second, and after that, it starts moving at a constant velocity of 45 meter per second till 30 seconds, which is in our consideration. So, the first question says, distance between the distance traveled by the car and the scooter in 50 seconds. Achhi baat hai. Okay, so for the scooter, it is easy, right? For the scooter, it's moving at a constant speed. So the distance travel should be how much? Time is 15, speed is 30. So that's going to be how much? 450 meter is the distance traveled by the scooter in those 15 minutes. Sorry, not a problem. Coming to the velocity, like the car, we know that the area under velocity time graph gives you the displacement. The area under velocity time graph gives you displacement. The area of this triangle, let's say OA, and maybe this is B. Area of this triangle would give you the displacement of the car in 15 seconds. Well, that's a triangle. So for the car, that should be how much? Half times of base is how much? Base is 15 times height is how much? 45. Okay, so that's going to be a decimal value, not a problem. 15 5 is 75, carry 7, 15 4 is 60. So 675 upon 2. Well, that is going to be the meter. So that's going to be 33, 7.5 meter. You can see that the car is still behind the scooter. Well, the difference should be how much? Quite easily done. Difference of the distance should be, that should be how much? 450 minus 337.5. Well, that should be the answer. Okay, so yeah, you can do it. You can actually do it. So this is going to be how much? Decimal 5, 9, it's going to be 2, 4, going to be 1. Well, that should be the answer for the question number 1. All right. Now, the second question was, how much distance was moved by the scooter and the car when the car catches the scooter? Good. Now, one thing is quite easy to understand. The car did not manage to catch till 15 seconds. The car was behind. Iske piche tha ji. That clearly means the car is going to catch the scooter anytime beyond 15 seconds, right? Yeah. So, let us suppose the car catches the scooter at any time t. Beyond 15 seconds, any time t. So, in that time, the distance moved by the car and the scooter has to be same. That's the only way in which the car can catch the scooter. So, the distance traveled by the scooter. Distance traveled by scooter. By scooter in those time t should be how much? You can say 15 times of, speed is how much? 30, that is 30. So 30 times of t. That's the point number 1. By the car, I know that in 15 seconds when it was accelerating, it has already covered up this much of distance, right? So in the remaining time, which is t minus 15 seconds, it is moving at a speed of 45. So this is how the distance would be covered. Now what I mean to say that in 15 seconds, it has covered this much of distance. Beyond 15 seconds, it will move at a constant speed of 45. So the distance travel should be how much? T minus 15 times 45. And within 15 seconds, it has covered how much? 675 upon 2. Now both of these should be equal. That would just give you the value of t. Quite easily done. All good? So you just have to understand the concept and you have to stick with that. Let me go slow. Okay, so now let us equate this thing. So you're going to have how much? 45t minus this time this, already we have seen that is 675 plus 675 upon 2, that should be equals to 30t. Bring it here, you're going to be 15t, that implies 15t, it's going to be equals to how much? This minus this is going to be 675 upon 2, and once I take it that side, that becomes 675 upon 2. Well, easily we know already, we have seen these multiplications. So the time beyond which after 15, time after 15 seconds should be how much? Total time should be how much? Some 45 upon 2 seconds to catch, which should be 227 seconds. So it will catch, the car would be able to catch the scooter in 22.7 seconds from the time they started. All good? Chaliye ji. So you can pause the video and note it down, and then we're going to move to the one more problem. All good. So I'm sure you guys must have understood this. चलो हम लोग और आगे बढ़ते हैं. Let's continue. I hope you guys are following it properly and you are able to do these simple graph questions quite easily. You are able to do these graph questions quite easily. Just keep in mind that the fundamental concepts, what does slope and what does area gives of these graphs, and if you could know those things properly, rest would be quite easily done. Chalo, so let's try and do one more question. So एक अच्छा question कुछ और करते हैं, ठीक है? Okay, so basically we have a Jee question. हम लोग उसको कर लेते हैं. Let's try and do a Jee question. Question number 3. Well, this was asked in some Jee exams. Okay, now it says that we have velocity time graph is given. Velocity and displacement is given. And this is like this. The graph is like this. This is the initial speed is v0. And here, of course, at the point x0, it becomes 0. This is, of course, u. No? Now, they're asking you to draw AX graph. Draw acceleration displacement graph. Draw AX graph. है ना जी? बहुत अच्छे. देखो कुछ नहीं. You can give it a try. You can pause the video if you want. And you can give it a try. And then we can sort of go ahead. कोई मुश्किल वाली बात नहीं है. है ना? Okay, don't get scared that it's a Jee question तो अपने को बैंड बजाना है, ऐसा कुछ नहीं है. One thing is quite easy to understand. This is going to represent, it is representing a straight line. It's representing a straight line, and the velocity is decreasing when the body is moving it's actually decreasing with the displacement. The velocity is decreasing with the displacement. अपना simple से कम हो रहा है. I want to have AX graph. So basically Vx is given, AX we have to find. तो कहीं ना कहीं we have to make some relation between the A and V. अच्छी बात है. Now we know that velocity x graph is a straight line. इसका equation लिख सकते हैं क्या? Can we write the equation? Of course we can write using y is equals to mx plus c. Since the slope is negative, we're gonna put y is equals to minus of mx plus c. है ना जी? कोई दिक्कत इसमें किसी को? Anyone has any doubt as of now? It's a graph is sloping down, so we have to have y is equals to minus m. Now what is going to be the slope and what is y? Y is v. So v is equals to, slope is going to be how much? Negative of v0 upon x0 times of x plus c. What do we need? We need your sort of acceleration. We need the acceleration. So can I just do one thing? Can I just differentiate this with respect to t? कर ले इसको differentiate कर ले with respect to t. So what we'll be getting? We'll be getting what? dv upon dt. क्या हो जाएगा जी? चलो ये हो गया dv upon dt. So this is going to be how much? Minus of v0 upon x0. This is going to be what? dx upon dt. है ना? Okay. So what is the constant? Constant is how much over here? The constant has to be v0. लिख लो इसको. Let us put v0 over here. Now if you look at this thing, dx by dt, that should be how much? Velocity. So what we have, dv upon dt is what? Acceleration. And that's going to be minus of v0 upon x0. And this is going to be your velocity plus v0. Do we have the equation of velocity? Yes, we have. This is the equation of velocity. We can use this to substitute the value of v over here and the job will be done. अपना काम हो जाएगा है ना? So what do we get? Acceleration should be equals to how much? Minus of v0 by x0, negative of v0 upon x0. V has how much? Same thing, we're going to put it here. So we should be getting how much? You can multiply this, you know? So we should be having how much? Negative of v0 upon x0, chalo ji, and this is going to be x plus v0, and then we'll have v0 over here. You know? तो इसको ओपन कर लेते हैं. Let's open it up. This is going to be how much? V naught upon x naught whole square times of x plus this is going to be how much? V naught है ना, y is equals to mx plus c. बढ़िया. तो y intercept is positive v naught है ना. ठीक है. Okay, this becomes 0 ना. After differentiation this becomes 0. Okay, why the hell I've written it? Anyways, because that's a constant है ना, so this is okay. So a नहीं रहेगा जी है ना. बढ़िया. Now this is going to be how much? V naught whole square upon x naught. This is your acceleration. कोई दिक्कत? Okay, and we have minus sign, तो इसको minus. We'll have minus sign. ठीक है ना जी? Now this also is a straight line graph. If I want to draw the graph between a and x, see this. So if you just resemble it, if you sort of do the comparison with y is equals to mx minus c. This gives you a negative y-intercept. This gives you a negative y-intercept. Kitna? Minus of v. So here we have the graph, let's suppose. This is your a, this is your x. Y-intercept is minus of v square, v naught square upon x. So somewhere here, let's suppose this is going to be minus of v naught square upon x naught. Slope is positive. Means graph is going to going up. We only have to get it till x naught. So till x naught, the graph is going to go like this. And this is the point when we have the x naught. All good? So that is the graph, x graph for this particular question. Ji, hai na? Any doubt, anyone over here? Nahi na? Chaliye. Now, note it down and then we're going to do some more questions over here. एक और question हम लोग करते हैं, है ना? Good. So you can pause the video and note down. Meanwhile, I'm going to erase this and give you a next question up over here. एक और question हम लोग करते हैं जी. Okay. So here we have the next question. I hope you guys are following the concept properly and learning the things quite well. Great. Okay, if you get some doubts and all, do connect with me. You have my email ID, you have my the comment box, of course. You can use the comment box to get connected with me. Okay, it's pretty hot over here. Okay, chalo, ek aur karte hain. Let's try and do one more question. The question says, maybe it was example 5. So here we have a graph. So basically we have a velocity time graph. We have a velocity time graph and it is given like this. From 0 to certain value, let's say this is 10. It is going to 0 to 10 at time 2 seconds. And from 2 seconds, it is maintaining a constant velocity of 10 meter per second till, let's suppose, 6 seconds. It's deaccelerating and coming down and going till you can say the negative 10, okay, negative 10, okay. It's going till negative 10 over here. Now it's again coming back. This was happening at time t is equals to 8 and then it's going back to the zero velocity at time t is equals to 10 and here is a 12. So this is the graph given to you. Now you have to find the average velocity. Find point number 1. Find question number 1. Average velocity. Average velocity. I hope this part is coming in the camera. Yeah, it's coming in the camera. Great. Now number 2 that you have to find is the average speed. You have to find the average speed. And number 3 is draw AT graph, that is acceleration versus time graph. So guys, these are the 3 sub parts of this question. Chaliye, now you can pause the video and try and solve it. Pause the video and give it a try. Then we'll do it together. You can just pause the video. Okay. I hope you guys have given it a try. है ना? Try कर लिया आपने? चले आगे. ठीक है? बढ़िया. So first of all, let us find the average velocity. Now, you must be aware of the fact that velocity time graph, the area would give you the displacement. Average velocity is all about the total displacement by the total time taken. I've taught you long time back, and maybe in the first or the second videos on the kinematics. So the average velocity would be total displacement by the total time taken. Also, this is the positive displacement, this is the negative displacement. All good? So keep a track of the sign. Keep a track of the sign. So this is, let's suppose, 10 over here. Okay, we can do one thing. We can find the area of this positive side, area of this negative side. We're going to add them up. Whatever comes is going to be the net displacement. Time we have, we're going to find the average velocity. This looks like a trapezium for you, right? That looks like a trapezium. So having the two sides, 8, and this side is going to be how much? 2, 6, 4. So this length is going to be 4, this length is going to be 8, and the height is 10. So the area of trapezium, area, maybe you can say area 1. I'm taking this as area 1. The positive part. Area 1 should be how much? Area 1 should be half into sum of the parallel sides, which is 8 plus 4, which is 12, times the height, which is going to be how much? 10. So 60 is the area of the positive side, so displacement should be 60 meter. So the positive displacement is 60 meter. You might be thinking, sir, the body is deaccelerating, how it is making a positive displacement? So you must be aware of the fact that even if the acceleration is decreasing in the positive way, in the positive side, it means the velocity is still increasing. The velocity is still increasing. Only when the acceleration goes in the negative direction, what I mean to say, if suppose this is a body, if the velocity is in this direction and the acceleration is in negative direction, that is when the body starts deaccelerating. Till then, the body will not deaccelerate. All good? So, this is going to be the positive. Now comes to this part, that let's say this is area 2. We all can see it's a triangle, so area 2 should be how much? Half into base. Base is going to be how much? 8, 12, difference is 4. Height is going to be negative 10. We can put a negative here and put 10 here, so that's going to be how much? 20 negative. So that is your displacement in the second part. To find the average velocity, we have to get what? Net displacement by the total time taken. Okay, I have a black marker here also. So the average velocity, answer to the first question. Average velocity. Net displacement 60 minus 20 time is 12. That is your meter per second is the average average velocity. So we'll be having how much? 40 upon 12. So 4 times 10, 4 times 3. So 10 upon 3 meter per second is the average velocity. We are sorted. We are done. All good? Now, coming to the next part, where they're asking you to find the average speed. Number 2 is the average speed. Number 2 is the average speed. Cool. So the average speed should be how much? Total distance by total time taken. So when we talk about the distance, as I've told you, the distance can never be negative. So what I'm going to do is, I'm going to add the magnitude of this and this. So the total distance, my dear everyone, please understand this. The total distance has to be 60 plus 20. We're not going to subtract this. No. That's going to be 80 meter. All good? And the time is how much? Total time is 12 seconds. 12 seconds, as we all can see quite easily. So the average speed. Average speed should be how much? 80 upon 12. So 6 times 2, 6 times, okay, 15. Okay, no, we cannot get rid of 6. So 12, 4 times 3, 20. That's going to be 20 upon 3 meter per second. Just develop this. Just develop the average velocity. So that is the average speed. So 2 part we have sorted. 2 part हमारा हो रखा है. Now we are coming to the third part, which is the draw the AT graph. अपने को AT graph draw करना है. Okay, so it's quite easy to understand. From 0 to this time 2 seconds, the body was accelerating. It was accelerating. From here 2 to 6 seconds, the body is moving at a constant velocity, so the acceleration is going to be 0. From here till here, the acceleration will be same because the slope of the line is not changing, so that is going to be same. Of course, from here to here, it will have a different acceleration. है ना? तो ठीक है ना? कर लेते हैं, draw कर लेते हैं इसमें. Not big deal. Okay, so let's suppose this is your AT graph. I want to draw it here. AT graph for this particular question. है ना जी? Okay. From 0 to 2 seconds, Acceleration should be how much? Change in velocity upon change in time. That is 10 upon 2, which is 5 meter per second. So from 0 to 2, it's going to be 5 meter per second square. So let's suppose here we have, this is your 5 meter per second square till time 2 seconds. 2 to 6, the body is moving at a constant velocity. So it will be having a 0 acceleration. So from 2 to 6, it is having a 0 acceleration. From 6 to, let's suppose 10. What is the final velocity? Minus 10. What is the initial velocity? Plus 10. So what is the acceleration? Okay, maybe I can use this part. Acceleration is all about change in velocity upon the change in time. Now, here we have change in velocity is how much? Final minus the initial upon time is how much? From 6 to 10, that is 4. That's going to be how much? Minus of 20, you know, minus 20, so minus 5 meter per second square. That's going to be minus 5 meter per second square. So from you can say what? From the 6 to 10. 6 to 10, okay, 6 to 10, 6 to 10, it's minus 5 meter per second square, minus 5 meter per second square. Now from here to here, it was moving at certain velocity of minus 10 meter per second. At time t is equals to 12, it becomes to 0. So the acceleration in that phase should be how much? A should be change in velocity, 0 minus of minus 10 upon time is 2. So this gives you 5 meter per second square. So if let me extend it here, it's coming in the camera. Okay, so this is 10, let's suppose. Then from 10 to 12, it's going to be again 5 meter per second. So let's suppose this is 12. So this is going to be 5 meter per second square. All good? I hope you guys have, it's almost 37. Okay, fair enough. I hope you guys have understood these good questions. Okay? So, there are several questions that we can do on the graph. There are several questions that we can actually plot on the graph, and we can do that. Okay, Jee. So we'll do one thing. That should be okay. That should be okay for now. We have done 5-6 questions. Let's move on to the next part now. So yeah, I will just stop myself on the graph questions over here. If you guys want to do more questions on the graph, just do let me know. I'm gonna make one more lesson on this graph question, or else I'm gonna stop it here and I'm gonna move on to the next part, which is the projectile. All good? Then I'm gonna move to the relative velocity, or maybe we can do relative velocity in 1D, and then we can do the relative velocity in 2D once we do the 2D motion. So basically, the projectile is going to be motion in 2D, and that's not going to be a difficult one if you know the 1D motion properly. Trust me. If 1D is okay, you can get the 2D quite easily. Okay? All good then. That's all for the day. Thanks for watching, and do share and subscribe, and also press the bell icon to get the notifications of the latest updates on this channel. Yep. Till then, keep learning and keep watching. Keep studying. I'm going to see you in the next video. Take care. Bye-bye.